Okay, so in the last session, we figured out how to calculate the distance between 2 points on the globe. So we were given 2 points A and B in terms of their latitude and longitude. And through a series of steps, we converted this to an actual distance that you would need to travel if you were, let's say, flying on an airplane or driving across some landmass between these 2 points A and B. Okay, so this worked really nicely for these points A and B, but whenever we have a calculation like this, we may want to do this for more than 1 point. We may even want to do this for hundreds of points, right? So what would be really good would be to functionalize this distance calculation so that we can easily repeat this calculation for any values of any 2 points A and B, basically. Okay, so we have some experience in creating Python functions. So let's create a new one that does exactly what we want. So remember, the functions need to be defined before we import parameters such as A and B. So what I'm going to do is come up here and define a new function. I'm going to call this function calculate distances. Okay, and I need to give this function some inputs, right? So if you think about our code that we wrote last time, the inputs to our functions, the input to our calculations here was really these things here. So these are the things we could change, which would change the point on the globe, let's say point A on the globe, or change point B on the globe. So we actually had 8 things we had to input: A lat, A long, A lat direction, and A long direction, and similarly for B. So my inputs to this function calculate distances are going to be A lat, A long, A lat dir, A long dir, and then the B versions of all those things. So I might just copy and paste to make it a bit easier for me. Okay, B and B. Okay. So now, assuming that we pass these 8 parameters into this calculate distances function. Okay, what was the first thing we did to calculate this distance? Okay, well, the first things that we did after we defined A and B was we converted these latitude and longitude values to northings and eastings. So what I'm going to do is I'm just going to copy, so I'm going to cut actually, and I'm going to paste those values in our new function. Now immediately there's a slight problem. You can see that this line here is indented, but all the rest of them aren't. So we need to make sure that all of our functions stay indented. So I just highlighted that and then press tab to indent them. That may possibly work differently on your system. Okay. Then if you recall, once we calculated these new latitudes and these new longitudes, we converted those angles in degrees to radians, and we called the radian version lambda and phi. So what I'm going to do is, again, I'm going to cut, and I'm going to paste those in here. Okay, so now we convert to northings and eastings, and then we convert our results to radians. Okay, then we were able to calculate the Cartesian components of both point A and point B. So again, I'll copy that into our function and make sure everything aligns properly. We then calculated 3 things: delta, degree distance, and distance. So I don't really want the print command, so I'm just going to copy these one by one. So delta, degree distance, and distance. Okay. I can leave the print commands down the bottom here. Leave those in there. I can't get it to move up. Okay. So now we've put all the steps of calculating the distance into a single function. The only thing we have left to do is to return the values of parameters that we want to know. Okay, so if you look over in our console, the three things that we really wanted to know in the last lab was the angular distance, which we called delta, the angular distance in degrees, which we called dig distance, and the distance in kilometers, which we called distance. So I'm actually going to return three things here. I'm going to return delta, dig distance, and distance. I might just put a space in there to make everything look a bit nicer. Okay. So now this function, this calculation that we did to calculate the distance between 2 points A and B is functionalized. So what I may like to do then is calculate those things using the function. Okay, so now I've defined my three functions. I've imported NumPy. I've defined my 1, 2, 3 functions. I've defined my 2 points now. And now I want to call, using my 2 points that I've defined, I want to call this function calculate distances. So, well, I might just copy this whole thing actually. Okay. So, well, tidy up a bit of white space there, probably here as well. So what should happen is that as we run this code, the code will read these points A and B. It will input these 8 parameters into this function calculate distances. We'll send those 8 parameters to this function calculate distances, and it will work through each of these steps one by one, and eventually return to us the values of delta, dig distance, and distance. Delta, dig distance, and distance. And then, of course, right at the end, we'll print out these values again. So let's save that and run that and see if it works. And so, lo and behold, we get the same values as last time. Of course, you can change these values. So what happens if we turn that into an easting? And what happens if we change this to, let's say, just 1 degree latitude? If we run that again, then well, of course, we get a different value of distance and angular distance in both radians and degrees, and also distance in kilometers. So again, you can use this to calculate the distance between any 2 points on Earth. Again, bumps north to the North Pole, perhaps this time. So really what we've done differently from the last lab is functionalize this. And this is going to come in handy for the next lab, the next video, where we might want to calculate the distance between the point A, well actually between this point A and multiple other points. So we may have, instead of just one point B, we may have several other points on the globe that we want to know the distance between, say, Palmerston North and several other cities around the world. Okay, I'll see you there.